Okay, we are going to look at, continuing our circle theorems, angles at the center.
Whoop-de-doo. Is that recording?
Yes. And it'll not be a long note. Come on. And today is the, what date? The 29th?
Yes.
Okay, and we're going to say angles at...
FYI, the board isn't on.
Oh, was it not? Sorry. So, angles at the center of a circle are double the size of the angle on the circumference. So I will draw a picture to show what I mean. So we need to put this. So here is the center point. And if I draw, that is the what?
Radius.
Yep. This is also
The radius.
the radius. Okay. And what we're talking about is if I have this angle in here, let's call it. Actually, I'll leave it that for a second. I'll come back to it. And the way I think about these ones is if you think about it as looking like an arrowhead.
What?
Like an arrow, you know, like in a bow and arrow.
Yeah.
So it's always that kind of shape that you're looking at, okay? And we're saying that this angle is always double the size of this angle. So the angle in the center is always double the angle on the edge, okay?
Makes sense.
So just as a quick example,
It's like all we need to know.
yep. No.
It's an oval.
Okay. So just an example with a couple of numbers just to show. 1. If this angle is 54 degrees, and I have to work out this angle, what will it be?
27.
Yeah, because it's half of 54, okay?
What did you look at?
Excuse me. 54 divided by 2. Alright, so just looking at this, this is then like a nice little program. So you can see angle at the center is 100, so that means that angle on the edge is 50. Okay, and it doesn't matter whereabouts this is, okay? So you could get something that looks lame. you could get something that looks like that, okay?
Ooh.
It kind of looks like the bow tie, but it's not the same as the other ones that we did, okay?
Oh, that's weird.
So the angle at the edge is always 50. Okay?
So we're gonna have to learn how to pick all these out.
Yeah, exactly, okay? But if you kind of think of the shapes. So the first one we did was isosceles triangle. Yep. So we're looking for triangles with two sides being the radius. We also did this one. The angle in a semicircle is always 90.
Yeah.
So you're looking for that type of shape. We also did angles in the same segment. Yep. Angles in the same segment are always identical. Yesterday we looked at the cyclic quadrilateral. What does this tell us? Opposite angles add up to?
Oh, opposite angles.
Say again? 180, right? Yep. Opposite angles add up to 180, but you have to remember that all 4 points have to lie on the
Circumference.
circumference. Yep. Okay, for that to work. Okay, opposite angles add up to 180, but all 4 points must be on the circumference. And then the one today is our angle at the center. Okay, so we can see that the angle in the center is always double the angle on the edge, okay? So in this case, the angle in the center is 80, so the angle on the edge is 40, okay? Kind of make sense? Yeah. Okay, so I've got a worksheet which we can practice. Not that, where is it? Yeah. And this is it. For those of you who are off, you can have a go at this. So we're working out the little shaded angles, okay? So for example, with this one, are we going to work out this angle? Yeah, it'd be half of 123, okay? Obviously, as you go through, they become a little bit more tricky, but it's exactly the same principle, okay?